In this module, we will talk about nomenclature, or the systematic rules we use for naming compounds. By the end of this module, you should recognize the importance of these rules and be able to divide compounds into different classes that we will then learn how to name in future modules. The first thing we want to do is figure out what is nomenclature. Well, it's just a systematic method for naming compounds. What this allows us to do is that no matter where we are in the world, we have rules to follow to learn how to name a compound. And this is important, so if we're trying to compare results or compare experimental procedures, we're all doing the same thing with the names of the compounds. And we're going to kind of subdivide this nomenclature into two major categories, and then we'll talk about some of the other subcategories for our inorganic compounds. So for organic compounds, these are compounds containing primarily carbon and hydrogen. They do contain some other elements, particularly nitrogen and oxygen. And the unique thing about carbon or organic compounds is that we can form long chains of carbon and change the way those atoms are connected to one another. All other compounds are classified as inorganic compounds, and within that we'll have some subcategories of how we name them and how we determine which set of rules to use. On this problem, I want you to identify all of the inorganic compounds. Please note you may need to check more than one answer. So when we're looking at defining inorganic compounds, it might be easier to look for the organic ones and eliminate those. Remember that organic compounds are primarily carbon and hydrogen with occasionally another element included, such as nitrogen or oxygen. And what I see here for C4H10 is this is organic. HCl is inorganic. There's no carbon there. C3H6O is organic. Lots of carbons and hydrogens, a little bit of oxygen. Sodium and chlorine, so we have a metal and a nonmetal there. That's an inorganic compound. CO2 is also inorganic. And C6H6 is organic. Lots of carbons and hydrogens. We're not going to go into a lot of the details of organic nomenclatures, but what I do want you to know is that we can actually break the names of organic compounds down a little bit and understand some of the features of the molecules. A lot of times on the packaging of foods or personal care products, we see these really long words and we don't know what they mean. Well, really, these are just parts of nomenclature. So when I look at organic compounds, instead of just telling me how many of each element I have in the compound, it also has to give me some information about the connectivity. So when I look at the end of the name, which is where I start, I see the ANE ending, and that tells me all single bonds. We can also have ENE or YNE ending for double and triple bond compounds. The hex tells me that I'm dealing with 6 carbons in my main chain or my base of my molecule. I have a methyl group, and the YL tells me it's a side group, and the meth is the prefix that tells me 1 carbon. So for organic compounds, the nomenclature can get fairly complicated depending on the size of the molecule, but we can still break it down into parts and identify the pieces and parts that go into making that molecule. Now when we look at our organic compounds, we talked about the ANE, the ENE, and the YNE ending. So here we have an ENE because it has a double bond, and so we see that double bond there. It doesn't mean we have all double bonds with carbons, but there's at least one. We also see there are other groups called functional groups that are added into a molecule. Here our functional group is an OH group attached to our carbon chain, and because of that OH, it gives it a certain functionality. It's going to react in certain ways. When we have an alcohol molecule, we have an OL ending. So when we look at other molecules, other types of functional groups, one example is an aldehyde. You may have heard of formaldehyde, which is a common name, not the IUPAC or nomenclature rule name. And what we see is we have an aldehyde. It ends in AL, like ethanol. And what we see in that molecule is a double bonded O and an H. Now we're not too worried about you being able to identify functional groups at this point. This is just a brief overview of just a very few of the many functional groups we can have that give a certain functionality, a certain reactivity to our molecules. We also see something that is ketone. A common one is acetone, which is used in nail polish remover. The ending of the name is O-N-E. And in this case, we still have our carbon double bonded to an oxygen like we did in our aldehyde. But now instead of having a hydrogen, we have two non-hydrogen groups attached to that carbon. Now notice we have a shorthand notation. We don't actually show the carbons in the middle, but they are actually there. Again, just a brief overview of what we see in organic compounds and just a few examples of some of the many functional groups present. Now what we're going to be worried more about in this course actually are inorganic compounds. And we've already talked about two types of inorganic compounds, our ionic compounds, or our metals and nonmetals bonded together, and our molecular compounds, so when we have two nonmetals bonded together. We will also talk about acids and bases, so things like HCl and NaOH or sodium hydroxide, and compounds that are hydrates, meaning they have some waters attached to them. Those are just very attractive to the water molecules. And so if I looked at a single unit of iron nitrate, what I would actually see is an iron nitrate unit surrounded by 9 water molecules in this particular case. Coming up in the next module, we're going to explore how to name ionic compounds.